So my name's Larry McCay. I'm the dev manager and architect for the security infrastructure group at Hortonworks. And this is my colleague Sumit Gupta, who's on the same team and is a technical lead for the Knox work at Hortonworks as well. Today we're going to talk about multi-tenant application development with Apache Knox, or a particular approach to do so anyway. It looks like multi-tenancy is a popular topic these days. So this is just our boilerplate disclaimer. Please read that at your leisure. Quickly, we'll just go over the agenda for our talk today. We'll start with a very high-level overview of Apache Knox itself, and some of the a little bit of details about the aspects that will be helpful for multi-tenant use case, specifically topologies and identity assertion. We'll talk very quickly about what multi-tenant applications are and how to recognize them or distinguish them from a typical SaaS application, and what the concerns are above and beyond what your typical, single organization application are. After that, Sumit's going to talk about our demo SaaS application. It's just a demo application that we've put together to illustrate this use case based on scoring applications for loans for small businesses. And we'll talk about the high-level requirements and possible design of doing it all in the application, or leveraging the services provided by Knox to aid in the development. Sumit will then go through through a quick demo to illustrate the use of the services and this application use case. And hopefully we'll have time for question and answers. So Apache Knox. Just a quick slide on our community and our history. We entered incubation in March of 2013, matured with a handful of releases, and graduated as a top-level project in approximately a year. And we've concentrated on turning our release cycles into a much quicker and easier tested cycle. And as you can see, over the last year or so, our cadence has really picked up, and we're able to release very timely. So that's been a focus for us. One of the really interesting things, while I'm on this slide, is that this use case is not actually a use case that we intentionally targeted either in Apache Knox project itself or even at Hortonworks. It's come completely from the community, and a number of users have talked about how they've been using Apache Knox in this way, and it's really, really interesting. And it's one of the most amazing things about working in open source, because people are taking your work and doing really interesting and innovative things with it, sometimes in ways that you didn't even intend. So Apache Knox at a very high level. We have three main sets of services that are really user-facing services. Our bread and butter, obviously, is the proxying of ACP resources in and out of Hadoop clusters and deployments. And we started out only focusing on the REST APIs, but we've since started proxying the Hadoop UIs as well. And for those who aren't that familiar with Knox in this way, what we do is we provide a single entry point that can be secured in multiple ways with our configurable provider infrastructure. And we take care of the interaction with the Hadoop cluster itself. So you can actually extend access to these ACP resources out to clients who typically have constraints about how they can authenticate. They can't join the Kerberos realm, et cetera. So we take care of the Kerberos on the back end through a trusted proxy pattern that's prevalent in Hadoop. So coming out of the proxy services, we were able to actually leverage our provider infrastructure to provide authentication services. And these authentication services are used together with proxying, and we have a pluggable provider infrastructure where you can plug in different integrations with different identity providers. We also have a feature we call Knox SSO, which is a typical web SSO flow protocol that we use primarily for the UI access. And there are integrations with Apache Ranger and Apache Mbari, Apache Atlas, and a generic Hadoop integration as well. So thirdly, we have client services. We have a set of classes that you can use either directly as an SDK to access the different HTTP resources in Hadoop. We also have a Groovy-based DSL to give you really nice kind of async operations in a scripting language for administrative tasks, et cetera. So all three of these sets of services can be used, and we'll show how they're used in this approach to multi-tenant applications with Knox. So one of the important concepts in Knox to understand for this talk is our concept or our deployment descriptors, which are called Knox topologies. These are deployment descriptors in which you define which services you want to expose. You define what authentication providers you want to use, what type of identity assertion you want to do, and what kind of authorization you may or may not want to do at the gateway. Each topology manifests as a unique URL from a single entry point, and the topology is reflected in the URL itself. Topologies typically can represent different Hadoop clusters. So you could have a dev cluster, you could have a production cluster, and they would be separate topologies with separate or unique, or separate or the same access requirements and providers. Or you can have topologies represent different access methods to the same cluster. So you may have some clients for which it's inappropriate to have username and password, for instance, and you want to use a token. So you might want a topology specific for token clients and one for username and password. So for this talk, what we're going to do is we're going to extend the use of these topologies so that they can represent individual tenants. Okay, so they'll be accessing the same cluster, but they'll be authenticating either different IDPs or the same application managed LDAP server, whatever you want to do there. So identity assertion providers are important in this talk as well, and their primary purpose is to establish the effective identity. The effective identity is the identity that we propagate back to the Hadoop services when we request some service, some resource. And within the identity providers, there are a number out of the box, so you can create your own. You can alter the effective identity, based on something that you know about the incoming username, the authenticated principal. You can alter that by doing simple mapping to another identity. You can use regular expressions to transform it in interesting ways, or you can concatenate prefixes or suffixes to it, which will be important as we talk later for user disambiguation. So in addition, identity assertion also establishes the security context for service level authorization checks. So we can do group lookups We can do principal group mapping so that service level authorization for the effective user can be done at the gateway with our simple ACL-based authorization provider or with the Apache Ranger Knox plugin. So multi-tenant applications. I think probably most of us have an understanding, but just so we're on the same page. A multi-tenant application is an application that's deployed to a shared infrastructure for all of the organizations that are using it. They're deployed to a shared deployment environment. It's a single application instead of doing isolation by having separate deployments of the same application for each tenant. It may or may not have shared data or tenant-specific data, and that isolation needs to be maintained. So the account context as a user in a multi-tenant application is you usually have an account within a larger organization's account in the application. So, for instance, I think Slack, you have a team, and your account is part of this team. So that's a multi-tenant type account context. And each of the larger organization accounts is a separate tenant. So the concerns of multi-tenant applications are very similar to typical single organization concerns, but with the added complexity of providing isolation across tenants. So tenants cannot be able to view, modify, or delete other tenants' data. Admins of the tenant for the application can only affect their own settings. They can't affect any other tenants, and they can't affect the settings or the configuration or anything about the application itself. And application admins cannot have access to tenant data specifically. So to protect against evil admin kind of scenarios. Authentication, users authenticate using a typical username. You don't want Bob to have to log in as Bob Acme, right? You want him to be able to just log in with his username and password. And then our security context where user disambiguation needs to be done so that the Hadoop cluster can enforce policies at the tenant level needs to be done so that you have the context of the tenant along with the user identity. Only authenticated and authorized users may access the system, and we need to be able to provide flexibility in authentication provider integrations. So you should be able to have a built-in LDAP server for onboarding users and tenants. And you need to be able to accommodate tenants who come to you and say, I want you to use our corporate AD or our SAML identity provider or whatever. So that's my piece. I think Sumit's going to introduce our demo LoanScore SaaS application and walk us through that.
Great. I don't know if I'm live. Am I on? Everyone can hear me? Great, thanks. All right, so we'll go through the LoanScore SaaS application. So this is certainly a very contrived scenario that we've come up with in terms of an application. It's also not fully fleshed out, but we got to do something to make the ideas a little more concrete. That being said, it's only somewhat contrived because, as Larry mentioned, we've talked to users of Knox that have actually done very interesting things that are very close to what we're going to show you. So it's it's like the movies. It's based on a true story, but it's not really real. So let's talk through the app. It's I'm going to play the role of somebody that's a guy in a startup and want to create a new application and disrupt the market because that's what we want to do. So it's going to be a loan scoring application. We're going to use alternate models for scoring risk, for example. We're going to focus maybe on small businesses, but you could potentially extend that out to individuals that want to be scored for risk. And the risk scores play into actually just lending money. So the idea would be I have a SaaS application that has these generic functionalities like machine learning capabilities. I have data models for risk. I can increase and enrich my models and my machine learning capabilities over time by adding more data sources. So for this very specific example, say it's a small business. You want to score their risk. Maybe some of the data sources are like Yelp, for example. So if it's a restaurant and has a great Yelp score, it's also been around for 10 years, then maybe I'm more likely to give it a loan than not. So stuff like that. Now, tenants in this scenario would be the lending institutions themselves. So I want to onboard lending institutions. They, of course, have their own employees, and they certainly have a lot of workflows, I'm sure, to actually give out money at the end of the day. But we'll focus on a specific user and a use case, which is the originator of the loan. So the originator is going to come in and start the application process for the loan. So he needs to be able to log in, obviously. So we need to think about various authentication integrations that we want to provide. So again, we're trying to onboard different lending institutions to our application. They can have their own authentication needs, so we need to be flexible there. So that's a requirement. They, of course, tenants, since we're talking about lending institutions, they, on top of our capabilities, may have their own algorithms. They may want to provide certain weights to, like my Yelp example, maybe Yelp is not that important to them, but the age of the business is. So how do they tweak and configure their functionality? That'll be tenant-specific configuration and settings. And of course, at the end of the day, to make it all work, they need to be able to log into their own subdomain that we'll provide and have their own branding and stuff like that. Slack's a great example, or Salesforce. Again, you'll have your own, tenant.loanscore, in our case, .com, for example. So those are my needs to go disrupt the market. This is not an architecture diagram by any means, but we threw up a few boxes that we know we want to think through and worry about in the realm of being a multi-tenant application and thinking about authentication and our needs to access Hadoop clusters and things like user disambiguation. So we'll go through these one by one a little bit. So tenant-specific authentication, again, like I said, we want to account for tenants coming in and having their own means of authentication. So if I were to write this application today and I didn't have Knox or anything in the picture, that is something I have to worry about and start writing code, figuring out how to do these integrations and making them generic. My business logic, of course, I have to write whether I use Knox or not. I do have to think about things like branding and stuff where the user disambiguation may play in, but it's more to do with the security context that I need to provide for the authorization policies to be effective. Then at the end of the day, of course, I have to access a Hadoop cluster where all the good stuff is. If it's a secure environment, it's more than likely it's Kerberoids, so I have to think about how I'm going to access these resources. And in my loan score scenario, I intend on using REST API calls to access my functionality in my cluster. So now let's see, so those were kind of some highlights of the pain points. Let's see what Knox can take care of. And as we're going through this and building out this demo application to kind of put it in concrete terms what we can do for multi-tenancy, we kind of found that we could take care of all these boxes that are now green in Knox. So we have, as Larry pointed out, we have the ability to provide authentication through various authentication services. You still, of course, have to do your business logic in your app, so we won't be doing anything there. We have providers, the identity provider that Larry talked about for user disambiguation. So we can provide some means of adding tenant affiliation to a user ID once they're authenticated. And of course, we have ways, again, as Larry pointed out, to access the Hadoop cluster, either via our shell scripts, our DSL, but of course you could just use curl. But when you go through Knox, and Knox proxies a cluster, then there's some ease with relation to worrying about things like Kerberos. All right, so just turning the diagram around a little bit just to explain some more implementation details of what we're going to do in our application. Now, since we're using Knox, we can actually leverage different pieces of functionality to make this really easy in our lives. Knox SSO is a provider that we have that provides the very typical web SSO flow, but it goes through Knox. So we'll leverage that. We'll proxy the application itself, the loan scoring application itself. And by virtue of proxying it, we also can leverage a provider, the identity assertion provider, so that we can do the user disambiguation. So that'll be nice. And of course, by using all our authentication services, like we talked about before, we can either do LDAP, we can do an IDP integration over SAML, or you can bring a corporate ID and corp ID, AD, and we'll integrate with that. So that's those pieces. And just before we go into the demo, to look at the flow a little better, because it's sometimes hard to understand what's going on in the browser. But let's say you're a user for good loans. And we came up with Bob because that was the most generic thing. And it so happens Bob belongs to these two tenants that we have. I forgot to introduce the tenants, but we have two tenants in our application, our demo app here. One is a good loans lending institution and an unwise lending institution. So these are two institutions. Bob is part of both of these institutions, not the same Bob, but the same name. And he's playing the role of the originator, so he wants to log into the application. So you'll bring up your browser, go to Good Loans, and if you have never authenticated yet, what happens is you're redirected to the Knox SSO topology for Good Loans. And that topology has configured inside of it its own authentication mechanism. In our demo case, it's LDAP. If authentication is successful, then you're redirected back to the application. And that is a very typical web SSO flow, so nothing crazy there. Also, the user principal will then be disambiguated. And what we're doing in this demo is we're tacking on the tenant ID as a suffix. So you'll get Bob_good_loans once you're authenticated there. So, and that's the identity that we'll propagate onto when we do our backend interactions with HDFS in this case. All right, so onto the demo. So let's see, let's start over. I don't know how clear or big that is. All right, so before I hit there, enter here, it's hard to see the URL, but it's a Good Loans domain, and it's actually proxied by Knox, so that's why you see the 8443 port and the /gateway, which is the Knox path. And then Good Loans path after that is actually the topology for the Good Loans tenant. And the last part of it, /loans, is really the service that we're trying to access, or a service, I'm using an overloaded word, but in this case it's in Knox terminology, which essentially maps to the application itself. So loans is our application, and that's where we're going. All right, so I try to access it, I've never authenticated, so it redirects me. And it redirects me through to the SSO topology. And one of the things I think I failed to point out properly is the way we've structured, at least the demo together, is we have a lot of these topology files for all these functionality, like the SSO functionality for the tenant-specific functionality around authentication, all within one Knox instance. You could have them in multiple Knox instances, but you can certainly have them in the same. By having them in the same, all you're doing for adding more of these is one file. It's a configuration file. That's the topology file. So it's very easy to scale out and do various compositions. So anyways, so here we are at the SSO login page. And you can see here the original URL is also there, so that once we log in, we can get back to the application. And I am Bob. So I've logged in, and I can start viewing previous applications that I've filed in. And you'll see, we did this for illustration purposes. We're, of course, known as Bob to the organization, but also under the covers is the disambiguated user ID, where you're Bob_Goodloans. And I'll try to illustrate further that these are all applications that can only be seen by the Good Loans originator. To see that, let's go to the other, I haven't imported the cert, sorry. The other lending institution, and they have their own branding page, and it's also Bob. And you log into Unwise Lending, who has some other applications. So each of these each of these lending institutions, they're the tenants. They have data that can only be seen by themselves. They also have settings that are specific to them. Unwise happens to be a very liberal lending institution, so it approves everything, typically. So these are two restaurants that are in the New Jersey area where Larry and I come from. So, for example, Yankee Doodle Tap Room is like a really old Princeton facility. Has really poor Yelp ratings, but it's an old institutional place, and we can give them $1 million or so. Farm and Fisherman is a newer place, really popular, and they're not asking for that much money. So they're maybe money combined with Yelp plus age, for example, in this case. Good Loans, however, is not that generous, and it rejected Yankee Doodle, but will happily give money to Farm and Fisherman. So again, you can have some, tenant-specific setting configuration, that kind of thing. Let's just add one application. Let's see, I'm going to cheat. Somewhere I stashed away Hofstra House, and I will never remember the street it's on after I leave. But here we are. And we'll ask for, I don't know, some amount of money. All right, so we did that. And again, just to really prove out that we can't see this. So Good Loans has no idea about this application. And it's specific to Unwise, and when it does get around to processing, it will figure out if it wants to give a loan. I want to show, it's a weird thing to show, I think, but I want to show the back end of this a little bit too. It's a very simple HDFS portion that we're going to look at. So Unwise and Good Loans have their own directories. That's the application that we just put in. And as you can see, it belongs now to the user Bob_Unwise. And the group permissions on all the application folder, as well as the applications, belong to Unwise. So some of the other people in here are, for example, Good Loans. And it will have its own group permissions on the folder and its own applications. And the third tenant, if you will, is really just LoanScore itself. And it has no access to either Good Loans or Unwise. But of course it has, its own scoring and other data in here. So that's how we structured it, so that we provide that segregation. From an authentication standpoint and access standpoint, I want to just show one last thing. I know we're getting tight on time, which is our Groovy scripts that all are part of the Knox project, and they make it, I think, fairly easy to put clients together or write further client libraries or leverage them in an application. So we have a library for this as well as a shell, so you can do some shell scripting there. So what I'm going to show you is one of them, for example, is the admin trying to access information. that's in his own folder. And I'll show you where he's trying to access information that's not in his own folder. So I'll do a bunch of scripts there. But just to go through this quickly, for this demo, I've hard-coded it here, which is obviously not a great thing at all. But we have a credentials collector API, and you can do a collector there and get them from command line if you wanted to, or somewhere else. What you do with our API is typically create a session. Our class there is Hadoop, and you log in one of various ways. Over here is just username, password to that gateway URL and topology. Once you've logged in and you have a session, you can use other request libraries, if you will, or request classes that make it easy to put together requests and dispatch them. So for example, we have one for HDFS. So all you need to do is HDFS ls, and you pass it a session, and you get back what you would normally get back from a curl request. So that's that. I've got a bunch of those scripts to show you then. So that, he's listing out some lone scored information there. That's the content of that file. So as you can see, he actually doesn't have information that's leaking in here from the actual application, whether it's the name of the restaurant, the address, or any other private information or sensitive information as you might perceive. Instead, what he can access and can hold on to is some of the data source information or metadata that he's collected. And then there's an ID to tie it back to the actual thing. For the last point to prove out, so say he was trying to access in an evil way, maybe the good loans thing, you'd get a nasty 403 forbidden back. Another set of examples is good loans, trying to access his own information through Knox. And just to really prove this out, this last script, if I were to crack it open, is trying to access Unwise's application, which he cannot. So you get a 403 again. So that's I think pretty much what I had for the demo, and we have time for Q&A. Yes, please. I don't know.
Demo application, how is the effective username being passed from not your application, and what other kind of data is passed at the same time, and what else?
Yeah, I wish I could. I'm trying to show the audit log. So, is that a good place to do this? The affected user, I don't know if you can see this in our auto log, but we have a provider that's essentially doing the concatenation and adding a suffix for the tenant ID, and that's pretty much it. Is that what you were asking?
I'm assuming the application we saw, that's running on a separate web server somewhere
Yeah.
inside your cluster, right? And how does Knox tell that application what to use?
So,
Is it like an HTTP header, or
so generally speaking, the applications and the trusted proxy pattern that's used in Hadoop is basically Knox will authenticate to the resource using Kerberos and then provide a do as query parameter or something other specific to the protocol of that service. So I don't know if you're familiar with the trusted proxy pattern, but you only want to accept those kind of identity assertions from somebody that you trust, right? So there's configuration in Hadoop for doing that kind of thing. For custom applications like this, Knox can also be deployed to require client cert to give you that trust relationship. And then you would then be able to trust the username or the do as query parameter. Yeah, so that's typically how it's done, and that's the default dispatch provider will do that. If the cluster is Kerberized, you'll get a do as. If it's not, you're going to get a user.name. Does that answer your question?
I think so. Is the source code to this demo on GitHub, or is it part of not your demo?
The source code for the demo is on GitHub. Yeah. And maybe we can, I don't know how to provide extra information after the fact.
We'll try to get it added to the slides or
Yeah,
something.
we'll figure it out.
Any other questions? Yes?
Just speak simple language. So the Knox actually allows the user to authenticate to a Kerberos cluster to get the Kerberos token and then impersonate the user to submit the job on Kerberos cluster and do whatever he wants. And then he reverses the proxy to outside world. It's like a firewall.
It's a proxy.
It's a
It's
reverse
not like a
proxy.
firewall,
Yeah.
really.
Yeah, reverse proxy.
Yeah, reverse proxy, yes.
Mm-hmm.
Yep. Yep. Yes?
Maybe as a general observation, to what you're thinking. So, it was one of my team that added the solar support in 11 because we want all access to our Hadoop cluster to be through Knox, but we're finding a lot of vendors don't necessarily play ball. Splunk is an example, so that and we continually find we want to do something with Knox that we can't do today. How much buy-in do you feel, or traction you feel you're getting? Do you imagine in a year's time everything will be, or is it still a bit of a hard sell?
No, I don't believe there's a hard sell there. I mean, the rate at which new components are coming into our deployments, though, there's constantly a little bit of a drag to adding the trusted proxy support in the standard way. Now, one of the interesting things about how we define our proxying services is we have a service definition where so you can declaratively describe the rewrite rules that are required for proxying your particular application or service. But you can also provide a custom dispatch so that if your application does support some sort of trusted proxy mechanism, you could write a custom dispatch for that, deploy it within the Knox class path, and just declare the class name, and our dispatch will take care of that. So the community is coming in with more and more service definitions, which is great to see. So I think adoption is really picking up, and I think it looks really good, actually. But we are trying to design features in a way to kind of help with that transition too. So the service definitions was certainly the first shot at making it easy to add support for new services and applications and stuff like that. Yeah.
Would I understand Knox is generally for perimeter security, right?
Knox is certainly used in conjunction with your perimeter security story. Your perimeter security is typically done with network security, with firewalls, et cetera. Knox is not replacing anybody's firewalls.
So, for such scenario, our use cases we've been using Ranger. So how does Knox compare to using Ranger? Because even Ranger policies would define which users have access to which directories as such.
Sure. Knox has an integration with Apache Ranger for service level authorizations. So if you're going to protect your resources in a layered manner, you can provide access at the service or access control policies at the service level itself. So Bob may or may not have access to Web HTFS, right? But so we can stop them at the gateway if you want to do that. And it's called the Ranger Knox plugin that can be configured as the authorization provider inside of the topology. And that enforces Ranger policies at the gateway.
So it's like 2 levels of security.
Yeah, which is a very common layered approach to security. Yeah. Anyone else?
And is it possible to configure without the ranger?
Yeah, absolutely.
If I have two tenants and one cluster and open policy, maybe for joining the companies, but the infrastructure is different and split it. And two LDAPs and one NOx and one cluster.
Right, and multiple topologies.
And own passwords and so on.
Yeah. Yeah. So what we demonstrated in this app, it was the use of a single LDAP server with the directory tree basically with separate OUs for the tenants. Right? So then in each tenant-specific Knox SSO topology, you had a search space that was specific to that DN with that OU, right? So it starts at a particular part in the tree, and you won't find the other. Yes?
So in your example, what was the reason to choose the Knox SSO provider, like in favor of just basic authentication? Like the fancy UI as login mask, or?
There were a couple of considerations. One is, yes, that's a good way to show branding. Another is we leveraged the use of the SSO cookie that's provided by Knox SSO in order to do the back-end call to WebHCFS. So we kind of got a couple benefits there with that choice. So what we do is you take the topology, the goodloans.xml topology, which is the proxying topology for that tenant, and you protect all of the resources in that with the SSO cookie provider, right? And then that cookie will get, presented by the browser, and that's when you'll be given access to the application itself, right? So we kind of got a couple different benefits. We would have had to make a different choice for the WebHDFS call had we not had the SSO cookie provider. Does that make sense? Okay. Time's up? Okay. Very good. Grab me after.